ISRO's remarkable journey in developing space technologies exemplifies the power of vision and innovation. In recent years, ISRO has achieved noteworthy accomplishments showcasing India's potential as a front-runner in the field of space exploration. The upcoming space docking experiment, Spadex from ISRO, is a significant advancement in space technology. This mission features two robust spacecraft designated as Spacecraft A and Spacecraft B. Both spacecrafts are built on an extended microsat bus, each weighing approximately 220 kilograms. These spacecrafts are designed to be androgynous, allowing either one to take on the role of the chaser during the docking process. The objectives of Spadex are to develop and demonstrate the technology for rendezvous and docking using two small spacecraft and to control the spacecrafts in the docked condition. Additionally, the mission aims to test power transfer between the docked spacecrafts. Key indigenous technologies in Spadex include sensors for rendezvous and docking mechanism, and inter-satellite link for an orbit exchange of data between spacecrafts. Spadex utilizes sophisticated docking technologies and tailored assessments to accurately measure distance, position, and attitude. The docking procedure is carefully structured into several distinct phases. The initial separation and control drift till 5 kilometers, followed by progressively closer approach phases that incorporate hold points from 1.5 kilometers till 3 meters for safety and control, culminating in the final docking phase, characterized by capture, retraction, and rigidization. To validate the navigation guidance and control during docking, several specialized tests were conducted, including the docking mechanism performance test for testing final phase of automatic rendezvous docking and undocking sequence, vertical docking experiment laboratory for testing docking mechanisms under controlled conditions, and the rendezvous simulation lab for validating onboard algorithms with real-time simulations. Detailed characterization tests at sensors level have been carried out in addition to system-level tests. Flight model special tests at spacecraft level were also conducted for sensors and mechanism performance verification. The spacecraft is equipped with payloads for standalone mission phases. These payloads will provide high-resolution images, aid in natural resource monitoring, support vegetation studies, and measure the on-orbit radiation environment, offering various applications. The Spadex will be launched from the first launch pad of the Spaceport of India Satish Dhawan Space Centre SDSC Shar, Sriharikota, by the workhorse rocket of ISRO's PSLV Coralone version to an altitude of 475 km at 55-degree inclination. The PSLV-C60 mission marks the 62nd flight of the Polar Satellite Launch Vehicle and the 18th mission using the PSLV Coralone configuration. PSLV-C60 is the first vehicle to be integrated up to the PS4 stage at PSLV Integrated Facility and then transferred to Mobile Service Tower for satellite assembly and launch. Subsequent to the injection of the Spadex satellites, the terminal stage of the launch vehicle, PS4, will be restarted twice to reduce the orbit to a 350 km circular orbit. The PSLV Orbital Experimental Module 4 will conduct scientific experiments on various payloads from ISRO, academic institutions, and private space agencies. With this mission, ISRO will harness India's vast potential in space exploration, paving the way for long-duration human spaceflight, setting the stage for the proposed Bharatiya Antariksh Space Station and landing an Indian on the moon by 2040. With each step forward, ISRO continues to inspire the nation and fuel the dreams of a limitless future in space.